Welcome back, everyone. I drew a nice little picture here. So this is the idea for the video. What I want to do is I want to take the game, and instead of just just using the main camera to render the game to the player, what I want to do is I want to render to a texture. And what that's going to allow us to do is we're going to be able to take that texture and then apply a shader, and the shader will give us the spectrum color clash. And the way we're going to do that is we're going to use the shader with the material. We're going to pass in the render texture, which is going to have black and white pixels. We're going to pass in two other textures that are going to fill in our color data, and then that is going to give us the classic ZX Spectrum color clash that you can see here in these examples. And the way we're going to do that is the render texture is going to be attached to a plane, and the plane is what is going to be the main camera is going to be pointing at. So we're going to have everything just looking the way that a ZX Spectrum should do. And we can use this on other projects as well, which is the best thing about it. And so yeah, let's get cracking. Let's start creating this this render texture. I should point out, however, that the ZX Spectrum screen is 256 pixels across by 192 pixels down. However, every pixel doesn't get a color. Every pixel shares it with another 64 pixels. So the 8x8 grid that makes up a character, that is where the spectrum color comes from. So there's only two colors allowed per attribute. Traditionally in the spectrum, it's called an ink color and a paper color. Ink is like if you think of the letter A, it would be the pixels that make up the A, and then the background color is the paper color. And it's a source of frustration amongst ZX Spectrum programmers because it causes a thing called color clash. But it also gives the spectrum its charm, and that's what we're trying to recreate with this, is the ability to give the spectrum its color clash. Thanks very much to whoever posted up this on Reddit. It's a good map of the 3 pages of the ZX Spectrum screen there. But yeah, let's get started. So like I said, the first thing I'm going to do is I'm going to create a render texture. So I'm going to go into here and create a render texture, which I can never remember where it is. Rendering, that'd be a good start. And render texture. And we want this to be 256 by 192. And it is clamp. It is also point. It should be 192. Yeah, and we're going to render the screen to this. Now, in order to do this and make sure I've got everything right, I'm going to change the solid color in here to be purple, usual magenta thing, so that we know that we're doing the right thing. And then test card. Why is test card? It's weird the fact that, did I leave that as, oh right, okay, that's why. Okay. We'll make that bright just now. And so if we get another camera, and we do create camera, and then this is going to be a render texture, so this is going to be our render camera. And our render camera is gonna be, where are we? This is gonna be orthographic as well. And what do we do? 192, so it's 96, isn't it? Yeah, that sounds about right. And it's gonna be 000. Except it's not gonna be 000, it's gonna be 128. And then 96. What's it gonna be? Hold on a minute. Where's our render camera? There's our render camera. Alright, so I was right with the 128. 128, and then that's going to be minus 96. Okay, I should have just borrowed it from the same thing there. Okay, so that is going to be our render camera. And our render camera, where are we? Main camera, render camera. Okay, and then what we're going to do is we're going to render this to text text. We're going to render this to our texture. Now here's the thing, I don't know how to do that in this version of Unity, because this is Unity version 6. Normally you would just say, oh, render to wherever it is. I'm going to have to look this up. One moment, please. So this is laying out exactly what I was going to do anyway. Essentially, I'm going to have a plane. I'm going to render the texture to that, and the reason why I want it to be a texture is so that I can apply a shader to it, and that shader is going to be the spectrum attribute, and that's going to give us the attribute clash, and we can apply that to other retro remakes. So if I go back into Automania here, all I had to do is just scroll down a little bit more and go to the output, and then we're going to drag our, oh, what is that? That's going to be our ZX spectrum, let's call it that, and then our render texture is going to be that, and then we're going to drag and drop that to there, and that's going to render this. Now the camera itself is not what we want it to be, so it's doing the right job, so it's rendering to the texture. However, like if I select main camera, render camera, okay. If I move my main camera now, so if I move this to, I don't know, over here somewhere. Yeah, let's make it 470. Keeping it 470, 9610. Okay. You can see that we now have this purple thing here. So if I go back to our main camera, and then this time I want to create a 2D object. Can I do a 2D object? I don't know if I can. I think I need to do a 3D object, and I'm going to create a plane. And that plane is going to be in 3 dimensions. So if I do that there, so you can see that it is there. So I want to make it, come on, there we go. So that is straight up and down, and I'll make it 470 along minus 96, 0, minus 10 actually. So in the game, that's going to be about here. And if we look at our camera, the actual game, it should, where's our main camera? Our main camera's at minus 10. Sorry. So if I make this 0, you can now see that we've got that here. Now our main camera is orthographic, which is correct. And if we make our plane 256 across by 192. No, 192. There you go. That's far too big, but it should be the correct dimensions, and it is. I think it's way too big. I mean, we could make it 25.6, and 19.2. Okay, so that's roughly about the same size as that. So there you go. There's our game there. And then for the plane, what we want to do is we want to have a material, and that material is going to be our ZX Spectrum screen material, and it is going to be the default one, which is nothing. We're going to change the shader for this, but for now it's good enough. And then I'm going to drag and drop that onto the plane, and that makes it nice and bright. And then for our sprite texture, what I think I can do, I'm hoping, is I can go in here and drag and drop, oh no, I can drag and drop that onto here, but I can't. Why can't I do that? Do I have to have a sprite renderer on here? No. Yeah, unlit. Is it unlit a better one? Texture. There you go. Okay, let's make it unlit. And then we can drag and drop that onto there. There we go. Okay. So now we've got that. Which is good. And then our render camera, that should be at -10. And there we go. We've got that there. It's upside down, but that's okay. We'll sort that in just a sec. And the way we can sort that out is we can, that's -90. But we also need to rotate on the Y, which would be 90. No, 0, 90. Hold on. Scene. Which is that way. That's us there. So that was 180 on the Z axis, and that gets us the right way around. Okay, but we still have the purple there. Now, if we go to our main camera, that's the purple that's there. So we want to have black, and that's it. Okay, that's the first step of it. That was not that painful. That worked out pretty good. So if I go to the render camera and I turn this off, oh, because it's already rendered to it, that's why. Oh, but if I move, it doesn't really matter, I guess. But if I move, oh wait, hold on a sec. If I move the test card, this should actually, it shouldn't block, it shouldn't go bleed into the edges here. So if I just drag this, oh, there we go. That's perfect. That's exactly what I wanted it to do. So you can see that we can see the blue behind there. So what we're actually drawing onto is the proper aspect ratio for the ZX Spectrum, and it should just scale, and we shouldn't have to worry about it. So if I go to free aspect, it should just scale automatically. We'll need to cull this bit out because it's obviously going too far, but we can move these things around, that's okay. But yeah, now we got everything, it's all pixel perfect. Yeah, that's a good start. Alright, next stop is getting attributes in. So let's flip over to this other project that I created, which is called Attribute Test. So we go to game here, we see that we've got, it's a black and white image. So if we go to the scene, it's just a standard image, nothing spectacular about it, and it has an attribute material on it, which is this thing down here, this attribute here, and it is based on a tint overlay shader, which is the thing that I created here, and that is inside Shader Graph. Now, I don't really know Shader Graph, and so I actually ended up I asked Gemini, which people go have their favorite AI ones. I just went with Gemini because I happened to be logged into my Google account, and I asked it how do you get started with Shader Graph, and so it gave me the sort of steps here. Now, one of the things I can never seem to do is minimize these things. I don't know why, or move them out the road. But essentially what's happening here is you take the UV coordinates in here, you take the main texture into here, and you have this sorry, you get the main texture here, which is the thing that you want to display. So this is going to be our render texture, and then this thing here, which is the overlay texture. Now we're actually going to have two overlay textures, and that's where it gets a little bit complicated. I wasn't entirely sure how I was going to do this, and we'll come to that later, but we'll get it working, the basic one working in just a sec. And then we just take the colors in there and then we multiply it here, and because they match up, then the colors they feed into this fragment shader here, which is our pixel shader. They match up, and then so they align correctly when here. Now this is a stretched out image. My hope is that because it's a 256 by 192 image, that it's going to match up perfectly with the image that we give it. So I have this PNG file here, so I'm going to go grab this just now. I'm going to copy that, and then over in here, I'm just going to create another image. Can I paste it in here? I don't think I can. Show an Explorer, art, and I'll paste that in there. So over here, we've now got our attribute there. So we'll make that 1, apply, and so on. So this one here, I don't know if you can see that, but let me just make sure you can see that. It's in frame. So this image here is a 32 by 24 pixel image, and the reason why it's a 32 by 24 pixel image is because the spectrum, and hopefully I'm going to do a bit at the start of this video to explain all this, but in that case, if you remember that the spectrum is 32 characters by 24 characters, so 32 characters long, 24 characters down. So this should match up perfectly with there, and then it should color in the image. And the idea is that we're going to update this texture and then display it on here. So I'm going to recreate this shader. Actually, I don't really need to recreate the shader because I can just copy it, can't I? So if I go to back to the project here, okay, here. So I need this attribute material here, and then this tint overlay there, and copy it. And am I going to get lucky? And it's just going to let me paste it in there? Nah, it's not going to let me do that, is it? So let me show an Explorer. And I'm going to grab the attribute material, and I'm going to grab the shader from there. And hopefully this is going to work. And I'm going to create a new folder in here. Actually, I'll create a new folder in here, in our actual project that we're working with. So I'll create this in here, and I'll call this ZX Spectrum Graphics. Okay. And then I'll show an Explorer, and then I'll paste those in there. And then this one here is based on tint overlay. Let's call this something better than that. So we'll not call it tint overlay shader graph. We'll call it ZX Spectrum Color Clash. Okay, and then that'll be an easy way to find it. ZX Spectrum Color Clash, and then that gives us that there. And then so our main texture is always going to be the render texture. So if we go back to art, and then we have our render texture here, and we can just drag and drop that in there. So that is our render texture there, and then our attributes is going to be this one here for just now. And so when we go to the game, we need to go to our plane here, and then our plane, instead of having where's the materials? Yeah, here we go. Instead of having ZX Spectrum screen material, we're going to give it the attribute material. So that is going to be, where are we, plane, and then we drag and drop that onto there. Boom. And then we have that there. Now, why is this all blurred? This should not be blurred. This is a bit of a problem, and we're going to sort that in just a sec. So if we go to our art and then go to attribute PNG, you'll see that it's tight there, clamp bilinear, but we want this to be point. And I think everything's okay, and then we click on apply. There we go. That's our attributes, and it looks pretty good to me. Obviously the attributes don't match up with what we have here, so I'm going to go create an image, and then we will have a look at how these combine, and then once we've done that, then we can figure out the paper color. So our paper color is going to have another attribute on it, so that we can determine what the paper color is going to be. But it's looking good so far. Let me go get an image, and then we can display it on here, and then we'll have better attributes than we have here. And I'll be back in a second. So I have the image there, so I'm going to go to test card, save, yes. I'm going to go to our test card here, and instead of having the test card logo, I'm just going to drag and drop this one into here. Why is that not doing that right? What? Oh, because that's why. Okay, sorry. If I go to here and then I sprite editor and then choose the point to be 0, 0, apply. Okay, that puts it in there, so you can see we've got these colors here, and then the same thing for this one as well. It's going to be the same thing as well. So let's just bring that back to 0, 0, and then apply. Okay. And then for our renderer, instead of having this overlay here, what we're going to do is we're going to drag and drop this on top of it. Boom. And now we get the cyan image there. So it's looking good so far. What we're going to now do is we're going to figure out the paper color as well, and the paper color is going to be an additional attribute on the graph. So if I double click on the graph, you see we have our overlay texture and our overlay color. So our overlay texture, I'm going to rename that as ink texture, and then I'm going to create another one which is also going to be a texture 2D, and it's going to be our paper texture, and our ink texture is, we're just going to call that overlay texture, overlay text, and then we'll call this our overlay paper text. Now here's the tricky bit, is we want to invert that image. So every time, so right now every time we see black, we're just ignoring it, we're just making it black, we're multiplying black by that. But what we will actually want to do is we want to tell it what color to use, and right now we're not doing that. So what we're going to have to do is figure out how to split those images. Now I put this through Gemini, and it came up with a solution which I'll just show you in a sec. So this is it here, and it takes you step by step through. This is the output for it. Unfortunately, I didn't save the actual screenshot, but I did copy the text. So what I'm going to do is go through this, and hopefully we can get our image. So we're going to take our generated image, which is going to be our sprites, which are just basically going to be black and white images. We're then going to use the color information and then print that on our textures, and then we're going to apply those textures there, and that should give us our nice little color clash. But in order to do that, we need to implement this shader. So I'm going to implement this just now. What we do is, alright, open this up first of all. So it's saying the white mask, add a compare node or step node. So I'm going to create a node, and it's going to be a step or comparison. Okay. And input luminescence or sample color. Okay. Edge. Oh, it's not that then, is it? So it's going to be a step. So step. So input is the sample color. Okay, so sample texture is going to come into here to our input like that. This is our main texture. Yeah, this is the main texture. So we're taking that in there, and then the we need a value. So float. And this is going to be 0.95. Bring that into there. Okay. This is where it gets a bit messy. Let me move some of these out of the road. Just move all this out here. Okay, so this is. There we go. Okay, so that's coming from here. Okay, so we're getting that there, and then the black mask is going to be, you can invert the white mask, use 1- node on the white mask to get the black mask. Okay. So in order to do that, the output of that is going to go into an inverse node. Inverse. 1-. 1-, there we go. 1-, so we take the output of that, put it into that. I guess is our black mask. So this is our, can I rename this? Nah, that would be too easy. So there's our white mask and then our black mask. Our black mask is going to be that, and then I then need to invert. Well, that's about as much as I get. Okay, and then that's gonna get. Is that gonna get me the right thing? I don't know if it is gonna get me the right thing. Because what I need to do is I need to select the black squares from there and then invert it. Because that's not gonna get me the right ones, though, is it? No, I guess it is. No, it is. I think it is. It is. So for this one here, we then want to put this through the mask. No, I'm confused. Hold on. So that's that there, and then we take that and then we multiply that. Okay, so that multiply there. So our multiply here is for the white part of this. So instead of this one, which is the input, take that out, and then for this we want to put that in here. I think that's right. So okay, so we haven't changed anything. That's good. And then this is our paper color that we multiply there, but we want to add it. We want to add those. We want to add that one as well. So we have our sample texture. So we have our paper texture, which is this one here. Okay. And we do our sample texture. Sample texture 2D, which is this one. So we take that one there, and then that goes into texture 2D. And then that one goes down to, it's very difficult to do this when you can't see it. I think it's that one there. Okay, so that's the same UV coordinates as the input texture, or at least they're all using the same UV coordinates, so they all match up. And then from there, I want to take multiply multiply, and I want to take the output of this, and I want to take the output of this, and that does that there. And then I want to add the two of them together. Create node add. And I want to add this one and this one. And then I want to output to this one. Okay. All right. That is actually progress. So that's good. So right now it's white because the input texture is defaults to white, I think. So that's good. So if we change, if we create let me create actually, if I go to here and we have our paper texture, if I drag and drop that in there, we should end up with a solid solid blue around there, because the text, the paper color will be black, but the border paper color will be cyan, and because the ink and paper are the same color, we should end up with this shape again. So we should end up with solid colors. So we'll drag that in there, and that looks pretty good. There we go. It works. This actually works. Oh my god. I'm genuinely my ghast has been flabbered. There you go. It's an ugly shader, and I'm sure somebody would come in here and laugh at me for it. But yeah, that's awesome. Okay, well that's good. So that was the bit I was worried about. The rest of this stuff is easy, or relatively easy, he said before he got into the weeds. But yeah, that's really cool. So yeah. So if we go and let's quickly go into Photoshop and create let's create red paper. And so what this will show then is that the red paper mixes in with let's go to border color here. So if we go to here, so we have our cyan there. So all of this is black, but we really want red paper. So I'm going to go and grab everything there and then do that, and do that. Don't want that. Let me duplicate that. Image. Where's duplicate? Duplicate. There we go. Paper. So I'll go there, and then for our paper, we will grab that, and then we'll choose a red color. And why is that not working? Never mind. Okay. And so our paper color is going to be red and black. So this is our red here and black here. And let's do paper there, save that there. Okay. And export PNG. And then that is color paper, save that. All right, so now we go back into our Automania. So now we have this one here. And we're going to change that to 0.1, apply, and then we need to change our to there, apply that, 0, and now we go to here, select that, and then we can drag and drop our border color onto here, and boom, there we go, perfect. That is exactly what I wanted. That is fantastic. So now we know how to do that. What's going to happen in the next couple of seconds is I'm going to go and I'm going to create an image. Then we're going to grab one of the sprites, and then we're going to have to figure out how we're going to get this ink and paper dynamically updated on each frame. And the color clash, I think, is just we're basically going to get it quote unquote for free because of this shader here, which is fantastic. Yeah, that's cool. Now I don't know how to collapse these, which is, oh, there you go, collapse all previews. No, I don't want that. View. Oh, who cares? It doesn't matter. Anyway, it's working. So let's walk through this shader again. So we have our UV coordinates that we use to then determine what pixels to choose. We have our sample texture here, which is our input texture. So that's whatever we want to display, which is our things that we render to the screen, because we did that in the last section. And then what we do is we take out the white parts of the screen, in other words, the ink parts of it, and then we just multiply that with the ink color. And then to get the paper color, we invert it. So we take our whites, they become black, and the blacks becomes white, and then we multiply that with our paper color here, and then those two multiplications then get added together. So when it's 0 or black or whatever it is, it becomes nothing, then you add those together, and then that becomes the other thing, and then we pass that into our fragment, which is a pixel shader. And yeah, that's the pixel shader node, and then we get that. Fantastic. Okay, brilliant. Let's crack on. Let's see what we can do with the rest of this game then. I've just created a default one here, so I'm going to go into our graphics here. Actually, let me grab these two here, which is the ink color and paper color. I'm just going to drag them into ZX Spectrum graphics, and then here I'm going to give the default ink texture there, and then default paper texture I'm going to give to there. So when we run the game, we're going to get displayed what we think we're going to get displayed, which is the level that we did in the previous video. So that's our previous video. So now what we need to do is we need to inject some color into this scene, and what I'm thinking is storing the attributes for each of these values with the objects that they're with, and then give a sort of run of what colors there are. The complicated ones are going to be this one here, which is the ladder, because that's actually two different sections. So yeah, I'm going to have to figure that bit out. The only alternative is to create blocks and then maybe render to those textures. That seems a little bit over the top just now. I need to have a wee think about that one. But yeah, that's the next step, is to figure out what colors we've got there. I think if we do it as runs, it makes sense. So if I go into here, scriptable objects, and then I create an attribute run, let's call it that. Run. Still rocking the 3-year-old Visual Studio. Yeah. Okay, so it's on monobehavior scriptable object, and we want to have public vector to position, and then we want to say public. Do we want color? Color. Yeah, I guess color, and public int, and then this is going to be run length. Okay, and that's our scriptable object. So we want a position, color, run length, and then for our items, we have to have an array of these things. So let's create another script, and we'll call that, let's get rid of attribute test actually, and then we'll call this, let's create a folder for this. So folder, and we'll call it ZX Spectrum, and we'll call this ZX object. object. And ZX object will extend from mono behavior, but it will also have public attribute run attributes. Now, do I? Yeah. Yeah, okay. Do I want to have a whole bunch of these? I really want them part of this. Well, okay, where we are, where we are. So there's our ZX object there. So if we go to our prefabs, where are we? So our scene, if we run the scene now, because we've got the default black and white graphics there, we can see what the scene looks like. So this one over here, the rafter one there, is cyan. So if we go to our prefab, so we have our rafters here. That's the rafters, those are red. And then the workshop one there, and then, oh, you get a girder, that's the one, girder floor. Okay. So girder floor is this one here, and we'll add ZX object. And then the attributes for that, we'll add another one. And oh, you can't create one, can we? We need to create one. How did we do that again? Oh yeah, here we go. Right, let me. So the file name is going to be our. Oh no, it's not in there. Sorry, what am I doing? It's in here. And we'll call this atters. And then we'll call it ZX Spectrum attribute run. Right, and then it would be kind of nice if this came with it, though. That's the thing. So, do we need to have, like, I wonder if we need to have an object in there. Like, can we create another object? Like, I don't want it to be. I want it to be. I don't know what I'm trying to say here. I want it to be part of the object. I don't want to have to like recreate it for every single one of these, but it's not too bad, I suppose. Okay. Let's create this one anyway. So we need to create an attribute file here. So ZX Spectrum attribute run, and then this is going to be the girders one. What's it called? Workshop floor. Okay, girder floor. Right, and then the color is going to be a kind of cyany color. It's not really like a dark cyan, so let's make that 22CCDD. That looks about right, and then we'll add that as a preset. Oh yeah, we need to give it that there. Sorry, let's get rid of that. Replace. Right, so that's our cyan color for the game there. And then we'll tweak those values for each of the other ones as well. Right, there's a cyan there. And then the run length is going to be 32. So it starts at 0, 0 and it goes for 32. Now it's 0, 0 from the perspective of this point here. It's not 0, 0 from on the screen. It's whatever the screen position is. So we don't have to like calculate, oh, this is going to be at whatever position. We don't know where this is going to be put at. And then for our standard ladder, the standard ladder is going to be a little bit trickier. So we're going to have create standard ladder, and that is going to be, oh, it's going to be top, isn't it? So standard ladder top. So standard ladder top is 1, 2, 3, 4. Okay, 4. All right, scrub this. Let me think some more. Right, I think it's this run length, that's the problem. So we need to do this as size. And then that makes more sense. So if we go back to our girder floor, this will update everything. So girder floor, so position 0, 0, size is going to be, it's going to be 32 along by 1 down, and that's going to be our value for that one. And so that means our standard ladder is going to be 0, 0, but it's going to be 2 along, 1, 2, 3, 4 down. So it's going to be 2 along, 4 down. And then the color is going to be, it's instead of CC there, it's going to be CCDC22. It's going to be that kind of yellowy, mustardy color, which is a sort of spectrumy color, and we'll add that as our swatch so we can get it back. So we're going to have it's at 0, 0, and it goes 2 along and 4 down, and that's the swatch there. And then this one here is going to be 0, 1, 2, 3, and then that's going to start at 4 and go 1, 2, 3, 8. 8. Okay. So we'll grab that one there, duplicate it, and bottom. And it is 4 down, and it's 2 across and 8 down, and this is going to be that color. I'll add that there. Okay. Okay. So that's good for now, and then for our this is for girder floor. We've got our attribute run, which is going to be that one there. And then for our ladder, we're going to add a component, which is going to be our ZX object. And the list is going to be this one and this one. And we'll swap these around just to make it look neat more than anything else. Alright, so now in our renderer, we need to have some kind of rendery objecty thing that it needs to know about all of these ZX objects and things. So in our where's our level builder? Our level builder is here. Okay, so we go grab that there, and it goes away and instantiates all these prefabs here. What we need to do is we need to get a list of all these objects and then pass them into our renderer. So let's have list ZX object objects. So these are just going to be the let's call them static objects just now. Let's just call them static. I think these are here, and then do equals new. Now we have our new objects there, and then for each one of these we want to say var ZX object component ZX object if ZX object ZX objects add ZX object. So if we have a ZX object, we want to add it to the list of objects, and then once that's done, we then want to update our the positions in there. So how do we want to do this? Let's have a public list ZX objects let's have a property called ZX objects, and maybe we do a register. I don't know how we're going to do this. All right, and then what are we doing now? Right, so we need to create a little render thing. Oh, did I not close that? Save. Okay. And then we will do a little render thing that will sit on our render camera. Main camera? Where's the main camera? Main camera is pointing there. And the render camera is pointing there. So that's the render camera there. So we want it on this one, don't we? Because we want it in the main camera, because the main camera is the one that's got, that's the one that's pointing at this one here. Actually, we don't want it on the camera, we want it on the plane itself. So this is going to be, let's call this something sensible. Call it ZX Spectrum screen. So this is going to have the attribute material on it there, and we want to have access to that. So this is probably the best place to put it. So that's in art. Let's call this scripts ZX Spectrum, and then let's call this ZX Spectrum screen. And where are we? ZX Spectrum screen. Okay. Oh, of course, because the attribute, I've just said that's the color, but it's not actually the color I want there. It's actually the paper color I want as well for each of these. Oh, that was stupid. Stupid. All right, let's fix that one just now. So go back to our prefabs here. Oh no, not our prefabs. We want it to be our attribute run. So we have our color, which is no longer color. It is now our ink, and we need our paper. And I'm not going to bother with the formally serialized as, we'll just fix it as we go along. Alright, so go back to our girder floor. Girder floor, and our ink is going to be that, and our paper is going to be a new swatch, which is going to be 0. Add that there, okay. And standard, so this is the standard ladder bottom, so that is going to be our ink is our green color, and our paper is our black color. Okay, and then our standard ladder at the top is the yellow, and the paper is the black. Okay, and then in the ZX Spectrum screen here, we'll add our ZX Spectrum screen. And let's have a singleton so it makes it easier. What are we going to do here? We want to kind of gather the things. I don't want to make it too complicated. Public void add objects enumerable. Okay, that's good enough. ZX objects objects equals new, blah 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 blah. And then our objects are gonna be that's gonna be new objects add range objects, and then we can't have that there. Oops. Awake objects equals new. Okay. So we've got our new objects here. Talking through my hand again there, sorry about that. We've got our new objects, we add that to the range, and then we're going to do something inside the awake. Void awake, not awake, update. So for our update, what we need to have is we've got our what do we have here? We've got our serialized field, private, plain, serialized field, private, material, what are we going to call that? Well, material, but we need a material instance. We'll get that in a sec. Serialized field, private, 2D ink, serialized field, private text to, and it's not inky, but it's going to be paper. And then private material mat instance, and then that's going to be mat instance equals instantiate material. So we want to create a copy of that, and we want to say plain dot material renderer component object. It's not plain, is it? It is just a 3D object, so it's going to transform plain dot get component renderer set materials material equals mat instance. Okay, so we want to make a copy of the material instance. We don't want to change it. We don't want to change that for everything because we could be using it for other purposes. And then we also want to make a copy of our, I think we can do that actually. Let me just jump into here. Texture, object. Okay, so we can do that. So I think we can create a copy of that, and then we can set that to be those values there. So we can have our private texture 2D ink instance, 2D paper instance, and so again we're making copies of these because we want to alter these at some point. Ink instance oh no, it's ink, isn't it? Jump the gun there. Don't want to make a copy of nothing. And then the update, that's when we're going to do our little magic and then start rendering these things. So we need to convert these two values on the screen. So we need to figure out where they are on the screen and then do the run of them. And the way that we can do that is go through each of the objects, figure out where they are on the screen, and then start poking those values into the array of the pixel data array. So I think you can do texture 2D dot set, no, is it paper instance dot set pixel data, haha, there we go, set pixel data, and then you can pass in the data. Set pixels, there we go. And then we can specify the colors which is perfect because that's where we want to pass in. So we want to pass in every single one of these colors. We're going to get these colors from the screen. Yeah, okay, this is good. This is good. Okay. Right, so color, and then this is going to be colors equals new color, and then it's going to be 32 times 24 because that's the size of the spectrum screen. So use an X instead of an asterisk. Okay, I haven't done that for a while. Right, okay, so that's going to be those values there, and then what we're going to do is we're going to say this is our paper color. So this is going to be our paper colors, and we also need one for our ink colors as well. And then we're going to go and grab all those objects and then plot them on the screen at a particular point in space. So what have we got here? We have our for each object and objects. We want to find out where they are on the screen. So where they are on the screen is int x equals transform.position.x divided by 8. Int y equals object.transform.position.y divided by 8. And then we'll have that as floor to int. That, and the same thing again. Here we go. So that's our x and y coordinates that we have there. And then that's our sort of start x and our initial positions there. But our initial positions are actually that's the on the screen. Oh no, that's fine. Yeah, that's fine. That gives us the coordinates in there. So the actual index value into the array. So that's going to be int start. Okay, int index. Sorry, for each var run in object dot attributes. Int x equals x plus run dot position dot x. Int y equals x plus run dot position dot y. That there. So that's going to give us our initial position as far as the x and y coordinates from the start point of this is. Okay, this makes sense to me in my head. So if we go back to, hopefully I haven't broken anything. So we run this game. So in this case here, we've got this point up here. So this is the top part of the screen. So this is at 0, 1, 2. So this is 2 attribute coordinates down, and it starts at 0. And it runs from 0 all the way through to 31. So that's the 32 columns that it is going to color in, and we're going to do that in this one here. So that's what this part here is. This is the x and y coordinate, and then the other part of it is we're adding the position at 0, 0. So we're starting at 0, 0 as far as the color run of this is concerned. So in this one here, we've got position 04 because this is the bottom of the staircase. Whereas this is the top of the staircase, it starts at 00. So it's just an offset from that position there. So we then need to do for int I equals 0, for int x offset equals 0, x offset is less than run dot size dot x plus plus. Oh, sorry, xo plus plus. For did it the wrong way there. For int y offset equals 0, y offset is less than run dot size dot y, y offset plus plus. Right. And then our int index is going to be our here we go, which is going to be our y times 32 plus our y offset. Oh, sorry, it's going to be that plus our y offset plus our x plus our x offset. Whew. Okay, and then we're going to say ink colors index equals, and then it's going to be our run dot ink paper colors index equals run dot paper. All right. And then at the end of that, we're then going to say ink instance set pixels ink colors, paper instance set pixels paper colors. Okay, so hopefully the math is right. The math is mathing, as they say. And so our x and y is there. Oh wait, hold on a minute. X, y plus o. Okay, so it's yeah, there's our x. That's fine. So our x is included in that position there. We're in position of y. Okay. All right, let's give it a whirl. Looks okay. Let's see if we can get some color on the screen. And not a thing. Spectrum screen. Oh, because none of that is being set. That's why. Okay. Right. Let's set these things up. So there's our plane there. Our material helps we set these things up, and then our ink is going to be our ink color there, and our paper color is going to be that paper color there. Okay. Let's see if that works. All right, let's run. No, but everything's set though, so that's good. Let's attach to Unity and see what we get. Put that there. Well, it's not running. Oh, there you go. Because objects is not being set. That's why. Right. Well, that explains it. So let's set that up then. Let's create a static. Let's call it region singleton. Private static instance ZX spectrum screen instance get if instance equals null, instance equals find object of, first object of type ZX spectrum screen. If instance equals null, var go equals new game object. Go. Type of ZX spectrum screen. Components. Turn instance. Okay, and then in our level builder, we would then want to do ZX spectrum screen dot instance dot add objects, ZX objects. All right, and in that way, it's getting called at least. Whether it works or not, that'll be this run. And if it does work, we're going to end the video and not jinx it. And it didn't work. Of course it didn't work. Why didn't it work? Let's figure out why. So let's go to our ZX spectrum screen again. And we'll attach it. Okay. Well, there's 4 objects, so it is objecting. So let's set a breakpoint down there. Index is 0, which is 0, 0. Okay, so this is our run. So the girder floor is that. Our ink color is that. Alright, okay, so let's set a breakpoint here and then see what those colors are. Okay. Oh. Oh. No, that's not good. So this is for the standard ladder. Okay. And this is our 4 size. Okay. Oh, that's not good. XX. What's our X? It's 21. X is 0, so 21. So that's only 21. 21 squares in from there. And that is our Y coordinate, which is 21, which doesn't seem right. Which is 20, so that's 24. Oh, it doesn't seem right at all. Hold on. Where's this coming in from? Oh, that's why. That would be Y plus Y, not X. X is too big. Also, when you're debugging stuff, have the console window open and then you'll see all the errors flying by. Right. Oh, we're getting more errors. What are we getting errors for? Oh, there's 2 audio listeners. Let's fix that for a start. My guess is there's an audio listener there. We don't need that. I can get rid of that component. Remove component for the render camera. The main camera should have that there. That's that fixed. And then Out of bounds is happening here. Okay, so attach the Unity, then we should be able to hit those out of bounds. And figure out what the problem is. Boom. Okay. So the index is minus 64. Well, that ain't good. So the index is... Wait, what? Why is y minus 2? What? Oh, right. Because the y coordinate goes down the screen and we want it, and down is minus on the screen. So if we go to let's take a look at this one here. So if we go to our scene here, that is at 0, 0. And if we go to this one here, you see it's minus blah, blah, blah. So our y has got to be math f absolute. There we go. And that'll give us the positive part on the downside there. Alright. These are the little bugs that you get excited about. It's amazing the fact that the shader thing just worked straight away. We're struggling with the X's and Y's. Oh dear. Oh, okay. So it says, it's not readable. The texture memory cannot be accessed from your scripts. You may make the texture readable in the texture import settings. Okay, so if we go to here, and I'm guessing there's probably something in here that says it. Advanced. Here we go. Read and write. There we go. I'll do apply. And then do the same thing for here. Apply. Okay. It's exciting. It's not that exciting. Oh, it's complaining. Text uses an unsupported format. What? What's the unsupported format? Alpha source. What if I do an alpha source of that? Okay. Point, no filter. Oh, sprite mode, single. Apply. And do the same thing for here. So we do single. Apply. Is that right? Nope. It's not liking it. Is it RGB? What's the... I don't know. Input texture alpha. Compression. None. Format. RGBA. 32-bit. I don't know. And that was, let's do the same thing. So that's RGBA 32-bit. Resize. Mitchell. I don't know. Apply. Is that right? I don't know. Sure. I mean, I guess I'm setting the color RGBA. Maybe that's, I don't know. Well, no errors. So that's good. But also, texture not working. That's because I never set the textures. That's why. Aha, ha, 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 ha. So I need to set the texture of the input shader materials thing. So if I go back to our guy here, so our guy here is using this attribute here. And then the attribute itself, this one here is main texture. Okay, is that the name you call it, or is it the other name that you call it? I don't know. I think you call it the other name. It's the main texture. It's not main texture anyway. It's the ink texture. Let's change the ink texture and then see if that changes it. So if I go to here and then I do matte instance dot set texture, and then it's that one, and then we pass in ink. Is that going to change it? Is it? Is it going to change it? It's exciting. I feel it should change it. Oh, let's find out. Hold my breath now, I don't know why. Well, that didn't work. So my guess is it's probably not overlay text, it's probably the other thing. This was called ink texture. That doesn't seem right, setting the texture. I'm guessing, I'm going to check the instructions, the manual for this, and see what it says it should be setting it to. But my guess that's what the next problem is. Yeah, it's not that. All right, let me figure this one out. Okay, so it should be that. So if I set it to material, creating a version of that, and then we're setting it to ink. That's right. We want it to be ink instance, don't we? And then the other one is the paper texture, which is our overlay paper texture. So we need to do matte instance dot set texture. That overlay paper text, paper instance. Oops. Okay. All right. That looks good. I mean, everything looks good. Will it display something on the screen? Will it be colors? Will it be, I don't know, fried onion rings? You'll have to wait and see. Well, that didn't work. Oh dear. Why? I feel it was good. It was a good idea. Just not very well executed. Let me go figure this out, or else I'm going to be burning daylight here. And that clearly didn't work. I will get back to you in just a sec. Well, I figured out one of the problems. So if you add the apply, that then copies the set pixel, just sets like a temporary work store, and then it does something in the background when you hit apply. So when you run it, I'll just bring this in a little bit closer. When you run it, you get this, which is obviously not what I want, because it looks like it's going backwards from where it should be. So our objects that we set up are the ladder and the top one. So this is the value here, and this is putting this in at the wrong position. So my guess is that because we've flipped I think it's because we flipped the plane, because this is at some wee jaunty angle, if I remember rightly. Let me turn off debug, normal. Yeah, it's flipped 180 degrees on the z-axis, which is because it's backwards. I think what we need to do is we need to turn the camera around so that it's pointing the right direction. So it's flipped on the z-axis. So it's not doing what it should be doing. Actually, hold on a sec. I don't think that's the camera's problem. I think it's just the way that we're rendering the texture. I think maybe the texture's getting rendered the wrong way around. Let's figure that out. Actually, let's do 0. So it's just flipping it that there, but the other rotation is along this one here, which is fine. So that's okay. I mean, it is doing it the right way around, I guess. So 180. So yeah, so that's getting applied upside down. I don't think the texture is itself, because the texture is this way around. So yeah, a little bit more trying to figure stuff out here, I think. But it is coloring it in. My guess is that it's coloring in it's filling in the attributes correctly, is what I think it's doing, but it's just not filling it in the way that it should. Like, it's filling it in the upside down, round around kind of way. So if I go to the debug view, I can actually sort of see in here the ink color and the paper color of these values, and they do look right. They just look upside down. So I think what I'm going to have to do is flip the Y coordinate, I think, because yeah, let's try that. So if I flip the Y coordinate and I say this is going to be 24 minus whatever this is, that should flip it upside down, because it's going to be the opposite of what it should be. Well, did that even do the opposite of what it should have been doing? Hold on. Oh, that's weird. So it's showing that, but when I flipped it round there, it was showing the bottom part of the hoist. Yeah, see, it's moving that there. Okay, that isn't clearly not working. All right, let me go investigate a little bit more. This is definitely going the wrong way round, so it should be, it's increasing it, but it should be decreasing it. Right, let me take a look. Okay, partial success here. So I've got 23. So I subtract 23 from here to flip the coloring information upside down, because it looks like it's drawing the top to bottom as bottom to top. And then I added this down here, which is the so I'm subtracting that, but I'm still going along the columns, but I'm subtracting it there, and that's sort of kind of fixing it, but still the run for the blocks is a little bit weird. So I'm gonna add the hoist, which is a big block of colors. That's the white and black. So hopefully that will display correctly, and then we can go from there and just try and debug what's wrong with the ladders. It could just be the fact I got the ladders wrong, but yeah, it's looking sort of like it's gonna work. But let's plow on. I'll fix those. I'll add those attributes, and then we'll come back, and then we'll see if we can fix the ladder. Okay, hoist is looking good. So it's clearly there's something wrong with the ladders. There's a little problem in the attribute there for the ladder, but we're getting there. What happened was I added this -1 here because we're going down the image, which is technically up the image. But I forgot to add the -1 here, so that brings us to where it should be. But that was the only problem. So now we've got this here. I think what we're going to do is we're going to end the video with an object that will move around the screen. And this object is just going to be simple. It's just going to bounce around the screen, and when it hits there, it'll do there. But it is going to have an attribute clash against it. So what I want to do though is, I think I want to add priorities to the objects, but I'm not entirely sure of how I want to do that. So I think what I should do is have an add object there and then call it public int draw order, and then in the spectrum screen we can do sort draw order, and we'll make it negative. Sort O order by. So we're going to order by negative because that will then push all the ones that we want to draw later on the screen. So I want to have it where it's like if I put 500 in there, then that means that's 500 times more priority than a 0 one. Anyway, it makes sense to me. So let's create our game object here. So I'm going to create an empty game object, and we're going to put it 0, 0, 0, which should be on the screen somewhere. Where's the level built as 0, 0, 0? Game object is 0, 0, 0. Is that right? That seems right. Okay. Let's add, actually, sorry, I'm creating a game object. I want to create a sprite. So if I go to one of our sprites here, where are we? Sprites, here we go. So let's create one of these cog things. There you go, that's good enough there. One of those cog things. So that cog thing is going to have a ZX object associated with it. The draw order is going to be 50 because I want it in front of everything. And then the attributes, I'm going to create a temporary attribute here. So it's going to be in prefabs. So I'm going to create, and then let's call this mobs. And then we'll call this one fan temp. Fan temp. And we'll drag that in there. And then we'll create our fan temp attributes here. So the ink color is going to be a green color, and the size is 2 by 2, and then the paper color is black, which is that color there. Right, and then fan temp then gets our attribute there, and it is pixel perfect ZX. Is this one color clash? Nope. Screen material? Nope. 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 None. Do we not have one for that? A default material for that. Pixel perfect, there you go. Pixel perfect. Okay. And if you look at our game, you can see that it's at 0, 0, 0. And then when we run this, we haven't added it to the scene yet. So it's just going to be white on top there. In fact, it's not even going to be seen by the game. Because it doesn't exist in the game. So it's currently being rendered as black. So we'll do a little temporary trick to that. Well, actually, let's do scripts, and we'll call this mobs. And then we'll call this fan temp again, because we're going to get rid of this at some point. Fan temp. And we'll add that to our prefab. Fan temp. Okay. And then fan temp is going to register itself. So it's going to do ZX spectrum screen dot instance void awake, which apparently is not what I am. Awake. Oh, good grief. What is going on? ZX spectrum screen instance dot add objects, and it's going to be get component ZX object. And of course, let's get objects. So if I go to here, do void add object, ZX object, ZX object. All right, and that will. Oh, okay. Oops, sorry. That will add that to the scene, which means when we run this, we should see, fingers crossed, as always, a green fan at the top left-hand corner of the screen. Which we don't, of course, because we haven't set it up correctly. So let's go to here. So our fan there is there, and it doesn't like fan temp 753. Okay. Fan temp. Do I not have that? Oh, that's why. Okay. Let's just have that in start. It doesn't need to be. I mean, we can change the creation order of the script and all that kind of stuff, but it's fine. We'll just put it in the start method, and then it'll get called after a week. There we go. And then there's our green fan there. Now our green fan is green because it is on its own, but what we're going to do is we're going to move it. So we're going to have our public float speedx equals, and then let's make it 32 pixels per, doesn't really matter, that one there. And then void update. And we'll do pause equals pause plus equals new sx sy 0 times time dot delta time, and then we'll do transform dot position equals new vector 3 pause dot x pause dot y 0. Now why am I doing it that way? Because I want to make that an integer, because I want to make it pixel perfect, and I want to move it across the screen there. So our screen is going to be, that's going to be negative there, and then I want to say if the position of that, well, let's see what it does just now. So because it's added to there, we will get this for free. I'm saying we will because I'm now confident that when we run this, we're going to see some attribute clash on the Speccy. Well, it would be if we went in the right direction, I suppose. Did I? Hold on. Okay. Let's do main story 2. Well, we're seeing a bit of attribute clash. Well, we need to watch out for that for the mobs, but other than that, so it's drawing it in front of. That's not what I wanted. It's also very flickery, but you can see there that there is an attribute clash against it, and there as well. So there's our. We zoom in there, we can see we've got our attribute clash. But yeah, it's quite flickery, and I think the reason why it's quite flickery is because it's not predicting where it's gonna be going, so it's not so when we need to add, when we're moving something, we need to make sure that we're adding the attributes in front of it as well. So it's not good enough that we're adding it there, we also have to add it around there. So that's going to make things just a little bit more complicated. Because the leading edge is basically black ink on black paper. So it is rendering it. It's just that it's, see, you get better when you go through there. Let me slow it down a little bit. It'll be easier to see. 16. Okay. And then let's bounce it around the screen there. So we want to say if pause plus transform dot pause position. Oh heck. If pause dot x plus transform dot position dot x is greater than 256, pause dot x equals, and then it's going to be 255 minus 16 sx times equals minus 1. If pause dot x is less than 0, pause dot x equals 0, sx times equals minus 1. If pause dot y is less than is greater than 0, pause dot y equals 0, sx times equal minus 1. Pause, and then sorry, my voice is going. If pause dot y is less than 190, actually it's 192 minus 16, pause dot y equals 192 minus 16, sy times equals minus 1. Now bounce it across the screen there. So we're doing that one there is greater than 255 minus 16. Okay. Let me set it to be that and transform it. So running it, should get this bouncing around the screen a little bit. Although annoyingly it's not heeding my order by. Oh, right enough. Wait, what? is it stuck down there? Oh, right, okay. Because it's that. So it's less than that. There you go. Okay. Math is letting me down today, unfortunately. Alright, there we go. So it's a little bit slow. So you can see that the bleeding edge there, it disappears because that index is there. That went a bit weird. Anyway, you get the point. That's my point, is that we now have color clash working on the ZX Spectrum, which is on our game, which will be a ZX Spectrum game. Let me just get it in here so we can get a nice screenshot of it. Well, that didn't work. Transform exposition. Oh, right, okay, hold on. That's why. There we go. Alright. Let's get a nice screenshot. And then we can call it a day, because it's a fairly long video, this one. And yeah, there we go. So we got a nice little attribute clash there. Like I said, it's going behind it, but at least it's attribute clashing, which is good. There we go. So there's a good shot. Well, other than the fact that it's missing a part there, but you can see that the attribute there is clashing with this one here, and then this attribute here is clashing with this one here. So you're getting that kind of mix of colors in there. So that's good. That's what I wanted to get today. Really wanted to get the shader down. Now we have that, we can progress with the rest of the game. And yeah, let's crack on with Automania. Thank you so much for watching this episode, and I will see you in the next one. Don't forget to hit the like button if you like this, and subscribe if you haven't already. If you got this far, probably should. Doesn't cost anything. I will catch you in the next one. Thank you again for watching. Cheers, everyone. Bye.